Welcome to your favorite intermediate algebra class. We're going to talk about linear inequalities, especially in two variables today. So that's our objective, is to graph some linear inequalities. But first, let's talk about checking some solutions of inequality. So this first example here says, check whether the ordered pair 5, 1 is even a solution of this x minus 4y is less than 1. So, if it is a solution, it should give me that 5, 1 should satisfy the original inequality. So all you got to do is plug that in. So 5 is x, 1 is y, and you say 5 minus 4 is 1 less than 1. You say that's false. So 5, 1 is not a solution. It does not satisfy the original inequality. Now let's look at the graphing now. So let's graph a linear inequality in one variable, and we'll take you through the steps here. So graph x is greater than -2 in a coordinate plane. Okay, so two-dimensional system here. X is greater than -2. Well, when you're graphing these linear inequalities, the first thing you want to do is you want to graph the boundary line. So you graph the boundary line by, you make that inequality into an equal sign. X is equal to -2. But the boundary line, okay, this is just the boundary line. You have to determine whether you're including all the points on the boundary line. So if you have a greater than or equal to, if you have one of these two signs, you make the boundary line dashed. Okay, if your original inequality is one of those two, which you notice it's originally a greater than, isn't it? So we're going to graph the boundary line x equals -2 as a dashed line, meaning all the points on that line are not included in our solution set. Now, if it would have been one of these two, I would have made it a solid line. So just keep that in mind as we move forward with this. Okay, so graph the boundary line x equals -2 as a dashed line. So what would that look like? Well, x equaling a constant is always a vertical line, as we've talked about, and at an x value of -2. Whoops, I was supposed to make that dashed. This is supposed to be a dashed line. Okay, there's our boundary line. Okay, now the solution set is every ordered pair that satisfies the original inequality. Okay, so number 2 is, well, where's our actual solution set? Well, we need to determine where all these points are that satisfy the original inequality. So what we do is we pick a point not on the boundary line and we test it. Okay, now I always like to test 0, 0, the origin, because it's real easy, as long as it's not on the boundary line. So we're going to test 0, 0. Now we plug it in for x and y. So here's our original inequality. X is greater than -2. Plug in the x and y. Well, you notice there's only an x to plug in into the inequality. There's no y to plug into. So is 0 greater than -2? I say true. Now, if it's true, you shade the side point is on. Okay? If it would have been false, I would shade the other side of the boundary line. Shade the other side. Okay, so it's true. I say, okay, 0, 0 is on the right-hand side of this boundary line. That means 0, 0 is not only a solution, but all these points over here are solutions. Any point on there, like 1, 2, 3, 4, -1, guess what? 4, -1 satisfies the original. If you were to plug 4 in right there, 4 is greater than -2, right? So all these, the shaded region is again representing all those infinitely many solution points. And I mentioned that we had to have a dotted line, right? Because if you pick a point on the dotted line, like -2, 0, is -2, 0, is that a solution to the original inequality? You plug the -2 in. Is -2 greater than -2? Say false, so no. So none of these points on the boundary line, none of those are included in our solution set. Okay, so if they said is the point -2, 3, a solution? And you would say, no, it's on my boundary line, right? All right, let's do another one. Now we have two variables here. Graph 2y plus 2x is less than or equal to 4. So first of all, we're going to graph the boundary line. 2y plus 2x, and we just let it be equal to as, is this solid or dash? So I look at the original inequality, I say less than or equal to. So if I have one of those signs, right, it's solid. Okay, so I say as a solid line. Okay, so what do? Well, we put in slope-intercept form. Pi by 2. Looks like y equals negative x plus 2. So we go to our graph. Our y-intercept, remember our b is 2, so put that on there. 2. Our slope is that negative 1 in front of the x there, negative 1, so we're going to go down 1, right 1. Down 1, right 1. Put a dot, right? Down 1, right 1. We can keep going with this if we want to. And then is it solid or dash? We said, oh, it was solid because it was less than or equal to. So make this solid. That means all those points on that line are part of our solution. And now we say, okay, I got to determine which side of this I shade, right? Where are all my solutions to this? So number 2, I test a point. And I say, well, 0, 0, is it on the line? It's not, so I can use it. I love using 0, 0, but you could have used anything you want. You could have used like negative 1, 1 if you wanted to instead, right? And if you're testing that left-hand side there. So 0, 0 is the test point. Write the original inequality, 2y plus 2x less than or equal to 4. Plug in x and y. Y is 0. X is 0 here. Is 0 less than or equal to 4? I say, yeah, that's true. So, since it's true, I say, where was the point that I was testing at? The point I was testing was 0, 0 right here, is on the left-hand side. So I say it's true, that means all these points over here are solutions to that linear inequality. Okay, let's go to one more here. How about negative y plus x less than negative 2? Graph the boundary line. Negative y plus x equals negative 2. Okay, and is this solid or dashed? And as you say, well, strictly less than. Strictly less than. Again, if it's one of those two, it's going to be dashed. Right? And we obviously have the less than one, so this is dashed here. So make it dashed. Now I solve for y. Divide by negative 1, all these, get rid of that. So y equals x plus 2. Okay, put the y-intercept on. Looks like we have a y-intercept of 2 here. All right. Again, our slope here is the 1 in front of the x. So we're going to go up 1, right 1, up 1, right 1, up 1, right 1, and so on. This thing, though, is dashed. Okay? Number 2, test a point. Test a point. And the original was negative y plus x less than negative 2. Okay, that's our original inequality. Now I can test a point, again, on either side. You know, instead of picking 0, 0 this time, let's go, how about negative 3, comma 4? Let's pick one on this left-hand side here, negative 3, comma 4, just to change it up a bit here. I'm going to test negative 3, comma 4. So negative 3 goes in for my x, 4 goes in for my y. Okay, so we got negative 4 minus 3 is negative 7 less than negative 2. So that's true again. Okay, so I shade the same side. Same side that the point is on. okay? Again, if it would have been false, so I'm shading this side, right? Shading that side. If it was false, I would have shaded the other side, okay? Like for instance, if we'd have picked 0, 0, let's say we'd have tested 0, 0, right? So we're testing on this right-hand side. Negative y plus x less than negative 2. You plug 0 in. Is 0 less than negative 2? I say, oh, that's definitely false, right? So I say, well, I was on right here, so I'm shading the other side since it was false. See how it gives you the same solution there? Okay, we'll see you guys soon in class.